Evening all, how are we all doing? And a happy Friday to everyone. We've done a little bit of shopping for Black Friday, but we've just come back from like a Christmas fair in our local town, which was really cool. I came back with some loot. I have toffee apple mead, which I shall be drinking on stream. And also some elderflower and lemongrass tea, which I'm still drinking from the mug you gave me, AJ. Look, it's still going strong. It's very nice too. Yes. The mead is toffee apple mead. Very nice. There we go. Toffee apple mead. Just very nice. They had a few different ones there. I had to taste them all, obviously, just to be sure. And yeah, that was the one I liked the most. I also have a genuine vintage Viking drinking horn, which may or may not have been made last year. And I got nothing to put it in. It comes with a stand, but I haven't built the stand, so I'm just going to have to use a glass. Far more boring, but still. Anywho, so we're going to be working on a star system designer tool this evening. It's one of the things that we planned to make for backer star systems, but we're just going to roll it out for everybody. And the difference between the backer version and the everyone else version is that the backer version will have the ability to submit those star systems to a central database where those star systems will be in the game for everybody, whereas the non-backer version will only work on local games. So you can design and add as many star systems as you want for your own personal local game, and if you start a multiplayer server, we hope that we can have those available on a multiplayer game you host, but it will just be for your game and games you host. But hopefully we can get some progress done on that tonight. We're literally starting it from scratch, so we'll just have to see how far we actually get with it. It is indeed binary, yeah. Right then, let's go to Mini-Me. Now, speaking of designing planets, I was messing around with some planetary terrain. So this is a GPU-based clip map terrain. So it's not voxelized, so it can't be. You can't have like overhangs and things without using a static mesh. And right now, the foliage isn't using the nanite foliage in 5.7, which we will switch to, which means we'll be able to have trees all the way to the horizon, which will be very cool. Obviously we've got no sky or anything at the moment, but the idea is that this planetary surfaces should be like this detailed and this full of clutter and stuff, which would be very nice. It supports real-time stamping, like height map stamping, so if we need to put down things like a village or some kind of structure on the surface, we can actually flatten the terrain dynamically around that structure, which will be really cool. So we won't have like things sticking through mountains, hopefully. Haven't quite worked out what these little black squares are yet. I still need to fix that, but yeah. And it draws quite quickly. So if you're flying around in a shuttle, the idea is that you should be able to fly over the terrain and then look for somewhere to set down. Which is something I'm really, really excited about. But there's a lot of work still need to go in this. It's as much as we're generating a terrain, it's very simple at this point. This is very, very basic, simple terrain. And the ground clutter doesn't have any particular rule set associated with it. We don't have biomes or anything like that yet. But yeah, so we'll drive it from Unreal's PCG tools and hopefully come up with something that looks awesome. Right then. So I suppose to begin with, we need the main menu, because I think we'll put the Star System Designer on the main menu and have it as something that's available on there. Should have a main menu here somewhere. Oh, that looks like something relevant. Yeah. Okay. Guess we'll stick it down under settings somewhere. Got that for now. So we're going to need an isolated environment for this. And the way the system needs to work is we need to go through the procedural steps that we take for normal procedural systems, but with manual controls along the way. So we still need to, we look at, we'll start off with the central star, we'll look at the type and mass of that star, and then the age of that star will determine what we can put in that star system. Some of that code will actually affect and update the main galaxy, because right now we've got like Earth-likes generating around O-class stars, which is impossible. O-class stars won't have been around anywhere near long enough for an Earth-like world to exist. So there's a few tweaks we need to make there. But ultimately, we want the Star System Designer to kind of be a hand-holding device, so that the star systems that are being created are scientifically plausible and realistic. We don't want a system that's got like 10 Earth-like worlds in it, for example. So where you place a planet will determine where the next planet can go, and then that temperature range will determine what type of planet you can put there. Of course, yes, it was Thanksgiving yesterday, so happy Thanksgiving to anyone that was doing that in America. Or anywhere else. I don't know who else celebrates Thanksgiving, actually. Is it just in the US, or is it US and other? Ah, okay. Cool. Oh, I suppose that's a little bit like the Harvest Festival in the UK. I think the Harvest Festivals are around a similar time in October. It's kind of like our autumn festival here. So we need one of them. shall rename the button to System Creator just so that we are consistent. Sorry, Whopper, I missed your question. Planets are 1-to-1 scale, so they will be as big as they are in the game world. Basically, the way we're probably going to do this is we will have a two-dimensional terrain for the planetary surface. So it won't actually be a sphere. It's just going to be a 2D mapped surface where when you pass over one side, it will teleport you to the opposing edge. So you'll still have the effect of walking around a planet. It's teleporting you when you reach the edges. The north and south pole will probably be a little bit twitchy with that system, but we'll have to see. We might need to put a mountain around the poles just to stop you from getting to the point where it glitches out. But yeah, that's the general idea, because then we don't need to worry about gravity direction or dealing with things upside down. Exactly, binary. Yeah, the planets will be as big as the planets are. No more, no less. Right, so when we click that, we want to fade out the main menu. And then we want to actually load our map. So yeah, so where we're fading a loading screen there, I guess we can skip that and just open up the map directly. Which means we probably need a new game type. Or do we? No, we probably don't, to be honest, because we're not doing anything with it. So we kind of just need to open the map, really. Hey, Danger Mouse. Yes, Walper. Yes, so the surface area of the planets will be 1-to-1 scale with real planets. So the surface of Mars will be, the surface of Mars, same scale, same size, and we'll basically generate it on the fly. So again, it will be a large 2D area that teleports at opposing edges to give the illusion of sphericalness. And then as you move across the surface, we will rotate the skybox as you're moving. So again, to create the illusion of a spherical world. And then we'll just generate that as you go. A bit like how Minecraft generates chunks, but it'll be generating them in RAM. Or VRAM probably, because it's GPU based. The way I'm picturing this, AJ, is we're going to have a whole new map, so a whole separate level in the world, which I shall name here. So we'll call it System Creator. So it's going to open a whole new level. That level will have a UI on it, and then you'll have the system itself, like in front of you, generated in 3D. So as you're building and adding planets and things, we want to be able to show that in 3D, like in the distance with the menu in front of you. How we go about doing that scale wise, I guess we'll have a switch on there for for a 1-to-1 scale, so you can actually see the real world distance of things as you zoom in and out. And then we'll have a condensed scale, and I want a condensed scale on the holo display on the bridge too, because there's no way of getting like an all-in-one oversight of a star system, because obviously the orbital tracks get larger and larger and larger the further from the star you get. So it would be nice to have one where all of that is condensed, so that each planet is shown just a few centimeters away from the next one in terms of the size of the holo display, so we can condense the full star system into one image. And we'll do something like that for this tool as well. So yeah, I want it to be a very visual thing, and I also want to be able to focus on each individual planet, and give you the ability to spin it round and zoom in and out, because as you're going through, to begin with, just seeds, and then in the future more finer control over different surface elements, so you can change the size and the shape of the continents and how high the oceans are and all that sort of thing. I want fine control over all of those different things, so that you can truly customize that system. And I suppose, so doing it via seed is quick and easy, because that's already there, already built into the system, and then you only need to save the seed. By allowing fine control over each slider, then of course we need to save the values for those sliders, and also load those values in. So when that system is generated in the game world, it's no longer relying on a seed to generate those values. It's actually specifying, sea height of so many meters and that sort of thing. So I imagine it's going to be one of those things that we evolve and add complexity to over time. My goal for this evening is to at least get to the point where we're able to input a seed and see the effect that has on the surface. So that should be the menu bit done, and then we need to, I guess we'll stick this in the Starships folder. I've called this folder Starships because that's where all our Starships will go, but I'm also putting like the main menu stuff here, my test playgrounds and that sort of thing. So we'll have a new folder for System Creator. Basically anything that has a level as a starting point will have a folder in this folder. Right, so that's our map, which is just a blank level with literally nothing in it. So we're going to have to create ourselves a widget on here, and we'll probably have a, wow, do we need a spectator pawn? We probably don't, to be honest. Basically, yeah. It should be possible, CSI. So the idea is, once we have systems scanned, then when you go to the astrometrics, you should be able to bring all that up. So any data that you have existing, and we don't track yet where that is in the in-game computer system, but it will be there somewhere. So when you go to astrometrics, you will be able to recall all the scan data that you've scanned to date, and you'll be able to review things that you've already scanned. So planets that you scanned a week ago, you'll be able to bring up the details for that in the astrometrics lab. And that will also be the same for the custom systems as well. Oh, Sophie, thank you. Yet again, you are super generous, and it means a lot. Thank you very much. Let's just make sure that this is working. I always like it when the camera starts off in the rings. I need to bump that up a bit because it's obviously added some height to the menu. Okay, so we need a different fade there because it's just bringing that up, which is no good. Yeah, you'll be able to name all the planets, so you can call them whatever you want. So we're doing that. So it shouldn't actually be bringing in the loading screen at all. Interesting. So we're actually hiding everything. So where is that coming from? Is that something that's a hangover from a previous thing, maybe? Got that. Yeah, so it should be fading that out like that. But where's it getting the loading screen from? Oh, I wonder whether that's something to do with our game mode and our game state specifically. I think what we'll do is we'll set up a new everything for this so that we don't have any weird crossovers with other game systems. So we will make a new game state. Yeah, that should do us. Right, so we'll call that let's group all these together. System creator, game state. And we'll need a game mode for that as well. I mean, we could potentially just use the base game states, but we'll use that one just in case we decide to do anything weird with it. So we don't want any of our existing player controller stuff or anything like that. We'll just use the basic ones. And then where's our level gone? Yeah, we'll have a moderation queue on our website. So the idea is that as a backer, you'll need to create an account on the website. And that's how we'll track the moderation, the approval process, and also modifications to systems. So we definitely want people to be able to make changes and edit the system at any point. And once you make a change, that will then drop into the moderation queue. We will check it manually, and if we don't see any issues with it, then we'll just press the accept button, and it immediately goes into the game at that point. So the game will be reading backer systems from an external MySQL database. So it will be pulling those in whilst you're connected to the internet. We do also want to have a local cache version of that as well. So the idea being that every time you run the game whilst having connectivity, it will make sure that the local cache is updated to the latest version. If you're then playing without connectivity, then it will just use the local cache. So if any changes have been made to the backer systems, then that won't have been pulled through until you go online next. Right, so we want Star System Creator Game Mode. Just to make sure that we're not loading anything we don't want. Not doing anything weird there yet, although we will do at some point. Okay. So the behavior we're looking for is when we click System Creator, we should just get a blank screen with no loading screen, which is basically what we've got, even though it appears to have frozen. There we go. Right, yeah, so we should have nothing there, just a blank screen. So that's good, that's what we want. Right, so the next thing we need then, we need some kind of UI for this. Where is it? Where is it? There. So we'll call this rather imaginatively System Creator. I will make it a 2D thing for now. Obviously this is going to have to work in VR, so I'll have to make it like a proper 3D widget in the world like the main menu is, but for now, while we're building it, I'll just make it 2D for simplicity's sake. So I'll try and put the UI stuff like left, right and bottom so that we're reserving as much space for the visuals as possible. But for now I just want to make sure that this does indeed give us everything we want. So actually we want a canvas on there. Just gives us the ability to size everything. What I get. Right, so I just want to test getting this widget loaded, which means we need to jump onto the other level again. So System Creator, let's spell it right, that usually helps. So we'll build that, and then we will add to viewport, and then we will set input mode to UI only, and then we will get our player controller. That in there. We won't bother focusing the widget. Right, so that should give us just that test widget on screen and nothing else. Yeah, and then we should have mouse visibility at all times, which we don't, so that needs sorting out. This should definitely be doing that. I might make an actual separate player controller for this and do it on there, but no, I will. I will do that. The controller should do as I think. Can we not do just controller? Oh, fair enough. All right. I think that should imply self, but I'll get a reference to self anyway. And then on our game mode, let's change that to System Creator Controller. Okay. Still losing the cursor when we click on it. Although to be fair, we can do this from the controller as well, not bother with that. Weird. Okay. If we add... See, we shouldn't need a pawn specifically because we're only dealing with a menu. And the camera location should just be kind of strapped to 0. Although, if we want to spin the camera around and kind of do a slow orbit of things, then it might be useful to have a pawn we can fly about as a spectator. We shall see. Do you think it's because I didn't do show cursor? Which... Wow, how wrong did I manage to type that? Oh, yeah. I didn't tell it to show cursor. That would be why. Right, okay, we have a cursor, we have a menu, and we can add a button to that. Button. Which we can click. Doesn't do anything, but we can click. Okay. Good. Yeah, all the wrong. Yeah, the backer system database right now, it exists as a spreadsheet, and that spreadsheet is available in the backers lounge on Discord. If you go and have a look through there, you should see it in the pinned messages. So go check out the pins, and periodically I just basically take the data from that spreadsheet and put it into our SQL database so we can load those systems in the game. Obviously that's just a temporary solution. The full solution is going to be a web-based UI, where you create the system in the game, and then there'll be like an upload button within the game, because we want as much of it we can do in the game as possible, and we only want people to step outside of the game really for just administration and approval purposes. So all the design happens in the game, the submission happens in the game, and then we'll just have an external moderation and approval queue just to make sure that, you know, we don't get planets called Titty World in the game or names of that ilk, because it's going to happen otherwise. You can't, I've already claimed it. Right, so we know the UI is working, we know that the input's working. So we need... What do we need? We need everything, don't we? We need the whole gamut of everything for this. Let's just start with name. That's probably the easiest thing, isn't it? So this is going to be like really simplistic to begin with. So star system name colon, and then we'll have text box. Why is every single option expanded? Right, font 14. Right, so we should be able to type in a name and click save, and it will just name the system accordingly. Again, all of this we will make look good, but not yet. Now is not the time for looking good. Now is the time for making it work. So we then need, I guess, star system type. And we'll have a drop down. Oh yeah, combo box. I think we want the string version. But we need to build this combo box based on an enum. So let's make sure these are variables. So text system name combo box system type. Right, and then on pre-construct we want to be able to add option. To be honest, construct should do, I think. Oh no, if we do it pre-construct, we should see it in the editor. I always get these mixed up. No, we don't want an event dispatcher. Right, so system types. That's going to be enum star system. Oops. I do have an enum for this, I just need to remember what it's called. It's not the one I'm looking for. Hang on, I'll have that enum somewhere. I don't want to create a separate one. I want to use the one we use for the Galaxy system, so that if we ever add a new type of star system to the Galaxy system, it will automatically be there on that menu as well. Wasn't those? Is it that? Ah, that was it. Right, so basically this is what we'll use to define what type of star system this is. Obviously we do have other options here, and we can roll them in to the system, to be honest. So if you wanted to put a nebula somewhere, we could add that to the list. Yeah, I don't see the harm in allowing these to be included. But yeah, so it's sector location types. So again, from a galaxy design and game data perspective, every sector of the galaxy contains 1 million sector locations. So that's 100 times 100 times 100, which is your cube. And each one of those 1 light year cubes we're calling a sector location, and that is somewhere that content can be spawned. Generally, that's a star system, but it could be a rogue planet, an abandoned alien station, it could be just a free floating alien vessel just floating through the galaxy. It could be literally anything contained within that 1 light year cube. So they're basically our content cubes. So what we're telling the system is that this cube contains this thing. So we need that as pretty much our first input type, so we know what it is we're actually making, because we'll drive everything else from that. So that was sector location types. Yes, I know, I've changed the variable type. So if we do a switch on that, now we have all of that. It's just having a bit of a hissy fit because I changed the variable type. It really doesn't like it when I close that little check window. Come on, catch up. There we go, it's caught up. You could do a for each on an enum, can you? That's interesting. I don't actually know how to do that. So obviously we have an enum, which is a list of options. Typically, if you expose that as a variable, it creates the drop down automatically. But we want to make sure that we create the drop down automatically from this, so programmatically. I might have to Google that. Never be ashamed to Google something. Convert enum to combo box. Apparently you can for each it. You totally cannot for each it. What do we have here? suppose what we could do is we could make an array. Yeah, let's do it that instead. Yeah, I think what we'd have to do is make this an array. I'll let it actually finish this time. Save it having a hissy fit. And then we'll just do all the different enum options as an array. And then we can then just do a for each on the array. That's probably not how you're supposed to do it, but that's how we'll do it for now. So single star system, and then 2, 3, 4, 5, 6, 7, 8. This feels like a really hacky way of doing it. Yeah, and then we just do that. There's probably a much less hacky way of doing that, but that should at least do what we need for now. Yeah, they're all there. Okay, so star system. Obviously, we don't have multi-star systems yet. Good point, binary. Yeah. So we should be able to set our default option on that. Let's try that actually. We are just going to pass a string from this, so should be alright to do that. I just don't want to say star system twice in the list, like that, because that would be annoying. Wondering whether that only works if you've got the options pre-configured, so maybe we can set select. Yeah, we can. So no, that's not what we want. Ah, yeah, set selected option. That's what we wanted. Star system. Ah, there we go. Much better. So you shouldn't need to touch that until we have multi-star systems. Okay, so that's the second bit done. In fact, what we could do, we could make this even cleverer, and we could go, if that is 0, i.e. the first index, then pick whatever the first index is. It should still say star. That didn't work at all. Which is weird, because that should have worked. So 1 shouldn't be right. Okay, so that must be constantly reporting false. I'm just doing this for my own morbid curiosity. Like, surely index 0 is going to be reporting true. Or not. Oh, wait. I just realised what I've done. Of course, I'm doing it off the completed pin, aren't I? Of course that's not going to work. There we go. That's more like it. So yeah, so by default it will pick whatever index 0 is and make that the selected option. In the future we'll obviously check to see whether or not like this actually been saved or not, and then run it from that. Speaking of which, we will need a save game for this, or a save game file for this. In fact, why don't we? Click that, click that. Does save game exist? Custom systems. Actually, let's call it system creator. Let's just keep everything nice and simple. So, if true, then we want to save game to slot. We'll need to create our object for this, and then the slot name will be system creator. And otherwise, we want to create save game object. Oh, actually, we don't need that, do we? So, right now, so we only need this when we're loading a save game. I think we can bypass whether it exists or not and just overwrite, so that should be fine. We do, however, need to create a save game object and then set the variables and then pop that in there. So we need a save game class, so we'll stick that in there. Blueprint class. So just object should be enough, I think. So system creator save, and then we just need to add a variable on there, which would be our struct, which we don't have. this is going to be struct system creator. Right, so this is where we need to start building the data structure for all of this, which is where it gets a little bit involved. So the simple one, obviously, is system name, which will be a text. And then we have system type, and that's going to be our sector location types. And then we'll set that. That already is, that's fine. Right, so there's our first two save options. Now we're going to be saving this as an array. So in our save game object, we want to change that to struct system creator. System creator. Just call that star systems. Make that an array. Right, so we'll have essentially an unlimited number of star systems in this array, one per however many you create, and then each one of those struct array items is going to be this struct with all the data. So we're going to have a nested struct because obviously we need the base data for the system, and then we need a separate struct for system objects, so that's all the planets, and then probably a nested struct again for the moons of those objects. So we're just going to have lots and lots of nested structs. So this is going to be quite a chunky file when all the stuff's been added to it. Right, so this would be system creator save. Oh, did that have to be of type save game? No, don't open it in Visual Studio. Be gone. Sorry, I put that as a wrong parent class. There we go, system creator save. Right, compile that, and then we want to set system, set that even. Yeah, so thinking on it actually. So that should save the data. We'll save that for our loading thing in a minute. Actually, let's test this. So if we do a loading button as well, let's just test the loading and saving. Make sure that actually works. So we'll duplicate that. So that's button load. That one was button save. Drag that down there. Nine 985. Right, if we have you go minus 50, and you go 50, 150, minus 150. There we go. Right, so you are save, you are So we also need I guess if we click load system, then we need a drop down, or at least a list of all the star systems that exist within this array. So these are all your saved systems. So that gets saved to disk, and then we loop through this array to pull out all the systems, and we'll build a menu so that you can create multiple systems. Obviously, as a backer, you can only submit one of them, and we'll have some kind of UI element on there to just highlight the fact that this is the one that's been submitted to the game proper. Okay, so that's that. Right, so load system. Right, so if it exists, then we want to load game from slot. I want to cast to creator. I want to get star systems. I want to get the first one in the list because that's the only one we have for now. And then we want to break the struct. Get our system name, so then we go to system name, and then we will set text. Set our text to there, and then we will get our Ujima flip. And then on here we just need to pop that in there. Right, so that should be the loading and saving done. Except we do need to add to that. Actually, no, we'll set it for now, rather than making it an actual array of stuff. So if we just make an array like that, we'll always just have one entry while we're testing it, and then we will make our struct. So system name is going to be that. So we will get the text from that, pop that in our system name, and in our combo box we will do get selected option, pop that, actually no, so we do get selected index. Then we need to convert that to a byte. That should, yeah, that should do it. Because we need to convert the index of the drop down to the matching byte for the enum. And that should create an array entry containing the data we want. And then we can then load and save. Let's see. So right now there's nothing. If I call it, let's call it Jeff, and we'll make it a quadruple star system. If we now save that, that should be saved in our save file. And if I load that, hey, we're loading Jeff. Great. So Perfect. So the loading and saving is working. That's cool, Max. You mean your name's not Max? Okay. So we have 2 successes, which is good. So the next thing we need to add... Oh. Sorry, that one's lost on me. I ruined the joke. Correct, Anasi. Yes, we can't add multi-star systems because right now, star systems in the game are based on a central star being the berry center for the system. What we need to do is we need to take a step back from that and make a berry center as the core object in the system. And then that berry center will have other berry centers orbiting it, which in turn will have their own child objects. So we need a berry center centric system. That's a bit of a mouthful. Yes, so the berry center centric system will basically build a data set where we can have children of children of children, and build a hierarchical star system from there. I can fully get behind that, Max. Right, so we need another combo box. So combo box star type. So this one again is going to have to be driven by an enum. No, it's not a string, is it? It's an enum. Right, let's make sure that this is the right enum, because I have a more or less granular version of this. So let's just switch on that. But oh, of course. I could just do this, can't I? It's even easier. Yeah, that'll do. Ooh, that's not a complete list. That needs making bigger. Yeah, because I think what we'll do... So there's a bit of a chicken and egg thing here. We can go with like the super granular version of this list where you can select like a G2V class star, and then it will give you a valid temperature range for that G2V class star. Or you select G class star, and then whatever temperature you give it, it then selects whether it's a G2V or whatever. I think we'll do it that way for now, because otherwise I need to create each individual array entry manually, and I cannot be bothered. So we'll do it this way. O, B, A, fine girl, kiss me. LTY. We'll add those after, and white dwarfs and neutron stars and all the rest of them. Again, for testing, we'll just stick with those. Right. So we need various setup tasks here. probably just duplicate this one for a minute. So let's combo box star type. And in this case we want so O, B, A, fine girls, that would be 4. That should automatically select a G-class system as the default. Which it does. Hurrah, look at that, worked first time. So it'll always default to G-class because they're more interesting for creating a star system out of. Obviously you can then just change it. So this is where we need to start defining our valid temperature ranges, and then when you enter the temperature range, it then needs to come up with the actual proper star class, i.e. G2V or whatever. So we need to make sure we enforce the text box so that anything outside of a predefined range is rejected. Let's add the box first. So this will also define mass as well. The nice thing with main sequence stars is there's a fairly linear relationship with temperature, mass and radius, so that we can set that programmatically. So star temperature, don't need hint text in there. And then what we'll do, we'll add our temp range here. So we call that temp star temp range, make that a variable. And then we can do, what's a G class? Say 5,000 to 7,000 Kelvin. It's not that, but it's around that. Yeah, if we just hint at what the range should be. We'll just put there for Kelvin, and we'll make that so that it is numbers only. I think you can we set that here? We could make it like numerical only, but I guess it doesn't make sense if it's a text box. So we'll do it in the code instead. Yeah, you're completely correct, AJ, and I'm going to do it. In fact, we don't even need that then specifically, because it will just be on the slider, and then we'll have that, yeah. I think our star is like 6778 Kelvin or something like that. How well did I remember that? Give me the Kelvin. Ah, 5772. I'm way off. Am I thinking of the radius? No, that's 695,000. I don't know where I got that number from. Right, so we want a slider. Thank you, Writing Gamer. Yeah, slider is the winning idea. So we're going to need to set minimum and maximum values, as well as our step size. So I guess step size we can just set to 1. But the min value and the max value, we're going to have to set them in code. So we should be able to do that here. Set min, set max. Yeah. Yeah. Should be easy enough. I'll probably turn this into a macro, and then we'll call this macro both on construct and whenever we press load, because once we hit load we need to make sure that the options are set. We also need to make sure that this is updated whenever we change the drop down for star type. Maybe, yeah, if we just set it for the G-class range to begin with, and then when we change this, so on selected, what is it? Changed. Oh, it's there. Durr. Right, yeah, that. So on selection changed, we need to do a select on that. Oh, no we don't. Oh, of course it's a string, isn't it? We have to switch on string and then put in OVAFGKM. We're going to have to put these in like this. And then we're going to have to set these accordingly, because we can't do a select. I don't think we can do a select on a string. Oh, we can do a select on a string. All right, ignore me. I'm talking nonsense. Oh no, we can't. No, I'm not talking nonsense. Yeah. Ooh, ah. Yeah, I'll get to the dwarf stars, don't worry. Yeah, we'll refine it, Kaji. Right. So on selection changed, I think we'll ignore this because I really want the index from that. So if we get that, and then we'll do get selected index, right, and then we will get a copy at index. This should hopefully work. It's a weeny bit hacky, but then we can do a select. Oh, keyboard, come on. We can do a select on that, and then we only need to do this once because we simply do our minimum and maximum like that. So we're driving the minimum and maximum values directly from the enum. That's what we're setting. That's what we're using to set the drop down anyway, so that the index should always match the array. And then we just need to set our values. So whenever we change the selection, we just grab that and do that. That should work nicely. And it's a little bit of a hacky yet cleaner way of doing it. It's a shame they don't give you the index on this node, because that would be perfect. I mean, I don't think there's anything there that's, no, nothing that is useful. I don't think we can. Let's find. I mean, we can always do. No, because it's. No, that's easier. We'll do that. Right, and then I need in our Galaxy system, on the Galaxy Gen, we will have our valid temperature range somewhere. Hang on, let's get rid of all these tabs. Where are we? There. So look at our real world star data. Here we are. So here we've got these are the temperature boundaries that the game is using. Now obviously in the real world the relationship between spectral class and temperature, although it's fairly linear, there is a bit of leeway, there's a bit of give and take with that. So we've just adopted the closest match values that we can for that, rather than looking specifically at the spectral class. I've run out of tea, so I have to drink mead. Oh well. It's nice, you can smell the apple in it. It's quite Christmassy actually. I know it's toffee apple and you think that would be like Halloweeny, but it's got some Christmassy herbs. So O class would be from that to, let's put these tabs next to each other so I'm not getting myself all lost. So minimum and maximum. B class. Minimum. And maximum. So this is going to be mildly tedious, but fortunately we only need to do it once. Okay, so there's our temp ranges. And of course the other thing we need to do is similar to that. When we update the slider itself, we need to update the little text box to say what value it is. So slider, that's what I'm looking for. So on value changed. Fortunately, this one does give us the value, and then we need that, which I didn't make a variable just to be annoying. So we will set text, and then we will do format text because we want to add our K, so we'll do temp and then K for Kelvin. Pop the temp in there, and that should be it done. Shouldn't need anything more than that. My YouTube has crashed again. Let's just give that a quick refresh. Right. Let's see whether that works. So can't even scroll it. Just brilliant. Oh, okay. So that works. That's our B class range. I class even. B class, yeah. A class, yeah. So we need to actually, every time we change our star type, we need to reset the slider because it's not changing the value, and that will lead to issues. But yes, so that's working, which is good to see. Oh right, yeah, that's why it wasn't working. So our min and max was G class, so that's 5305 to 5989. Right, we should have a workable slider now. Yeah, there we go. Right, and then we need to set the current slider percentage to 0, although I might need set where's our slider? Just set value. Okay. So our set value will be that. And then we'll do a similar thing on here. So when we change our combo box, oops. Need to take those guys, pop them over there, and then the value is going to be the minimum, which would be that one. So that should reset this every time we change that now. So we're down to 5305, that's that range there. If we change this, yeah, there we go. Sets the range accordingly. For the sake of nicety, it might be nice to put it in the middle, maybe. So if we do that, hang on, so that minus that times 0.5 and then add that to that and set that as the value. That should give us the halfway value. Yeah, there we go. Math. And then this one would be $5989 minus 5305 is that times 0.5 is that, so 342 plus 5305 gives us a value of 5647. That should be our midway value. Yeah, so now it's in the middle. Great. Okay. So now what we need to do is we need to do the actual class of the star. Which we'll call like final star class. Actually, if we call it base star class, and then final star class, and then we will pop that in there as a calculated value. So that would be like, again, G2V class, or just G2V, I suppose. May as well type the whole thing out, why not? So text block, final star class. Right, this is going to require a lookup table, and we're going to need to steal the Galaxy Gem one, I suppose. No, actually no, it's not the Galaxy Gem one we need, it's the System Gen one. Well, mead used to be a medicine back in the day. It was for medicinal use only. Yeah, it's really nice. It's the Well, I think it's the oldest alcoholic drink, isn't it? Mead. Generate procedural system. Right. God, this needs some tidying up. So when we generate our final name for a system, oh no, actually, it's earlier than that, isn't it? Because we're doing it for the star. Is it that? So this is the list we need with all the star classes in it. Right, so that comes from there. So let's just find out where we are setting that. Oh, we're doing it separately. That's mildly annoying. Okay, but at least we can copy paste the collapsed node, and hopefully that will be all right. Let's just give that a try a minute. Yeah, that works. Okay. Yeah, so we'll probably replace that with an input. Okay, so similar to how we're doing this, I think if we we're going to have to drive it off of this one as well. So actually, no, we're driving off of this one, aren't we? So yeah, so the temperature that we select here needs to define what we do here. Although at the same time, yeah, we need to know what's currently selected, so we kind of need that there. So if we then switch on, actually no, we can maybe select that. Because this is outputting an enum. Yeah, so then the O class. So we need a separate lookup table, basically, for each class of star. And then here, all we actually need to do, in the case of that, and we just do that to string, pop that in there, and that should give us our final stellar class. But it does mean we need to go through each one of those. So we need to define the subclass for each and every one. Again, mildly tedious, but not as tedious as having to write it all again from scratch. Sorry, my phone seems really eager tonight. Okay. Oh, of course. And then we need to feed all of those an actual input. Wow. It's a shame that there isn't a rewrote node on that, because it means I'm going to have to do this about 80 times, I think. I think it's about 80 stellar classes, subclasses. Okay, one. Then we stick the slider value in there. Yeah, and then we're going to have to do this for absolutely all of them. I might just call it temp just to make those boxes a bit smaller. Right, so that was the easy bit, and then the not so easy bit is I just have to get rid of that, drag that over, and connect all the pins. You certainly get to see the glamorous side of game dev on these streams. The worst thing is if you drag it into like the min or the max field by accident, then it actually clears the value. And then you have to try and remember what the value was. Right. So now, obviously, oh no, it's doing it. Great. Hurrah! That seems to work. Yeah, quite pleased with that. That's good. I think we'll get rid of the decimal on that. That's not needed. I'm sure that gave us... Oh, yeah, there we go. That's what I was after. Yeah, we'll use grouping, maximum digits to 0. Right, that's better. That just gets rid of our decimals. We could also floor it to an integer, but that'll do. Yeah, it's better. Okay, I guess now that we've got our central star, I guess it would be nice to actually render the central star so that when we change the Kelvin and the class, we're actually changing something visible in front of us. So let's do that. I suppose ideally, I'm just wondering whether or not we use the actor that we're using for the actual stars in the game. Technically, there's no reason why not. I'm just thinking about scale. We can always... should we use the holo display version? Yeah, let's do that. If we create an actor for that, I think. What are we going to call this? System creator display. Yeah. Add child actor. Stick it in the middle, and we'll make that a star. Sure, we had a hollow version of this. Is this even the right one? That's the question. So obviously, right now, this object is the actual scale of a star. So we might need to move it quite a long way away before we see anything. Although what's giving me pause is the fact it's not actually showing anything. That should be visible by now. I think this is the one we wanted. Though I'm still not seeing like an orange highlight around the screen, like there's something big here being highlighted. Right, let's do this a different way. Actually, let's Just out of interest, is it... Oh, I know what I'm doing. Of course I'm doing it on begin play, aren't I? Of course it's not going to do anything. Alright, planet. There we go. That makes more sense. And there's the orange border I was looking for to denote the fact that we've got something huge selected. Obviously this is a 1-to-1 scale planet-sized object, and I guess we want to scale all that down. Right, planet. So if we add a post-process to this, right, okay. So we've just got a lit environment. Now obviously we need to configure these worlds. So I'm actually thinking about the atmosphere of these, because obviously the atmospheres are going to take their light from the star direction, but for the purposes of the designer, we want to be able to spin around them and see them in their full detail. So we're going to have to modify the atmosphere to work from all angles and at tiny scales. I think what the best thing to do is hang on, let's see whether we've got any test stuff here hooked up. So terrestrial planet. Actually, let's go with an Earth-like. It might actually want feeding with all the data. Yeah, so it's not passing through the configuration you need. So there we go, that's randomizing that. So technically every time we move that, it's gonna give us something completely random. And that's how quickly it works. But of course we need to drive that, and it's not doing the atmosphere. Okay. Quick as me, yes, you will be able to use a black hole. Yeah, the time one's a difficult one because it's static in space at the moment. The planet's not moving anywhere. So obviously we want it to appear how it would appear in the game. So I guess we need a toggle, to be honest, to show what it would look like under natural starlight and what it would look like under an ambient light like we've got now. Because during the authoring process, obviously we want to turn the ambient light up. Why can't we make that any brighter? Weird. I would have thought that would definitely make that brighter. So what I'm thinking, what am I thinking? So we need to be able to configure these things dynamically. So obviously we need to be able to, to begin with, just drive it via a seed. So you add a planet of the relevant type, you can choose its radius or whatever, and then we're applying a seed to that to determine what the surface looks like. Now the issue is all of the planets are they're obviously one-to-one scale, so the scale of the environment we're working with is on one-to-one scale. So really what we want to be able to do is compress that right down into something that's kind of within the scale of a typical point light, so that we can have a point light as the central lighting source in the world. I'm thinking we want to show the atmosphere as lit from the central star. So a point light is the only way of doing that. But obviously point lights don't work on a solar system scale, so we need to scale the model down. But at the same time, that will mess with the atmospheres. The math for the Rayleigh scattering and everything kind of falls apart once you start making planets tiny. So I'll need to fix that. Right, let's replace this with a star a minute, which means that's going to be wrong. So we want BP star static mesh cast to star. I think there's a randomize. Sure that, oh yeah. Did we not have a randomize? I'm sure we had a randomize for those, but obviously not. So normally that would be generating a surface texture, which it's not doing. I think we're just getting a white base texture. So we want to be able to sort that out. Doesn't help that our test mode is not connected. Oh, hurrah. I love it when stuff crashes. Yeah, mine neither. Yeah, so I think it's going to probably be smoother, easier, and less detrimental to the actual Galaxy Gen system if we set up a separate actor for the star that's a much smaller scale. Probably a bunch of stuff I can close here a minute. Get rid of these tabs, don't need that. Keep that one, and that one, and that one, and that one, and that one. Don't need that one. Get rid of that one. Right, that'll do. We were connecting that up. That's what I get. So I'll need to drag that back into the level again because obviously it crashed. Not seeing. Seeing any actor there yet. Let's anything? Giant star, anyone? Actually, we'll leave the holo display version on because it should stop it from casting a light. Yeah, we've definitely got something there. There should be all the bits of the star. And there's a star. Right. It's missing a couple of visual effects, but we will scale that down. Okay, so what we'll want to do then is start driving this from this. And I'm thinking right, let's duplicate that actor. And we'll make a system creator specific version of it, so that we're not messing with the one actually that's actually, you know, obviously driving the actual game. That was the wrong one, so we want that one, and that one. Okay, so we don't need any of that. This is mostly the lights. Light settings, light settings, light settings. And we'll keep that one because it makes sure we rotate stuff to the camera. So none of that's relevant. Yeah, we want all that to be visible. So that's that. So we don't care about the direction lights. We don't even want a direction light, so that can go. Don't want a star imposter, so that can go. Yeah, so all that can go. So we don't need any of that. Don't need any of that. Right, then we'll replace that one with the other one. So that's Star System Creator. Right, so it looks the same, which is good. Does that change the scale? Yes, it does. Great. Right, so we want to scale that right down. Like, right down. Yeah, so So we need to come up with a... but we'll stick with the actual radius in kilometers, but on the star itself, when we configure the static mesh, obviously we're timesing that by kilometers, so if we don't do that, then that means we're using centimeters instead. Which made it tiny. Right, and then we'll need to do a similar thing here. We're just scaling it all right down. Where's the actual disk gone? So let's hide that for a minute. So we want to not show them. Well, what I'm going to do is I'm going to actually have a compressed scale for the visual display of the system. Eventually we'll have a toggle for that, but we're not going to use the actual astronomical distances between planets. So it's going to be a stylized view of the system. Like what you see in like Starfield or other games, where you see like a condensed view of it. The issue we're having right at this precise moment is these guys are expecting to be much smaller. So I've probably missed something somewhere. This might very well need a whole bunch of tweaking. Let's just try that a minute. Getting there. Let's turn off those a sec. There we go. Starting to see some. This is all sort of basically an art direction thing. You want to get the scale so that you're not getting like harsh lines like this. That'll do, I reckon. Next. Right, so those were the painfully large ones. What point does the effect extend beyond? Yeah, looks relatively decent. Okay. Yes, this will be a digital orrery. Right, and this should be the prominences. So that was too much. I think 10 is probably the sweet spot there. Oh, or not, that's still quite big. Oops. Where is it getting the value from? Right, so the smaller you make the star, the more the greater an impact these values have. Okay, so obviously the star needs a seed, and obviously it needs to respond to like the scale and everything. So that'll be the next thing we do. Now I think to do that, it's probably easier to make a global event. So if we collapse all this into a function, right? Yeah, so we need that, that, and that. Oh, hang on. how much of this can we cram into here? I'm hoping all of it should still work. Don't need that anyway. Okay, so that's fine. So we just need to update star on the constructor. That should give us our star back. Right, so when we when we make a change on here, I guess we need to trigger a global event update. So we're going to need a struct, because we're going to send a data update for the star that contains all of the various bits and pieces that we need for that star. So we're going to need an event handler here. So I don't have that as a separate object, do we? Where is the miscellaneous there? No, so it must be under blueprint. Yeah, that one. So this is an event and update star. And then we need a struct for that. So struct star data. Let's specifically tag it as system creator, otherwise we might get that confused somewhere else. So we need so star class star type, wasn't it? Yeah, so I want the star type, which is the final star type, and we also want star temp, which is our float. Let's just try those two. I mean, that's at least going to give us some of the data we need. I suppose radius is going to be an interesting one, because obviously if we're doing a stylized, condensed system display, then the radius is irrelevant because the star won't change in size. Although maybe we can change it slightly, just to give the idea that, you know, an O class is bigger than an M class. Yeah, we'll do that. So we need to plug in that variable. So star data there. Okay, so that's just basically we're setting up our payload for a global event. So on here we will grab our event handler, And I will be using the gameplay messaging subsystem for this at some point, but for now we use the plugin because it's easy to remember. So we need to call global event by class, and the class is star data. Event update star, that was it. And we need to build that object, so I guess we'll do it pre-construct. So construct object from class, promote that to a variable in a sec, and that would be update star, promote that to a variable, event update star, and over here we get that, we cast to it, and then we need to set star data. Pop that in there as the payload, and there we need to make the struct. So we need, oh, it's the wrong star type, isn't it? Star types. Let's save all a minute in case this crashes. Star types. What am I missing? So enum star types. That's definitely... Oh, no, it's not, is it? Right, hang on. Of course, I'm not even, right, I'm not saving this as a variable, so right, of course. Because it's stellar classes is what we wanted. Right, okay. Now we should, yeah, now we've got the big list. Great. Which means that needs to be compiled and saved. And then where'd it go? There. The final star type goes into there, and we may as well promote this to a variable as well, because as we start using it for stuff, it's good to get stored. Star temp. to use the variable for orderliness. Oops. And then we'll add a custom event, which is update star. Okay, so that will be a separate thing. I mean, to be honest, we could have made that a function, but that'll do for now. So on value changed, we will update star, and on the combo box as well, we will update star. Although I think, yeah, because we're doing a set value there, I think that will automatically trigger this anyway, because we're doing that. So we don't need that twice. That should bounce through as a daisy chain. Right, so we're now broadcasting out that value. We don't need to cast to it, so that's fortunate. Great, that makes that even nicer. Right, and then on Star System Creator, we don't need any of that, do we? So on begin play, we need to bind global event. Oh, we need the event handler first, don't we? Grab our event handler, and then we will bind global event by class, and then the class would be update star, I think it was, yeah. Okay, stick in a custom event, star data updated. Star data updated. There we go. Right, grab our payload, cast to event star update star, and then we will get our star type. Oh yeah, get star data. Move. Break the struct. Right, and then we need to update star. But we need to basically drag in these values. So let's give a couple of inputs on here. We want star temp. Oh, to be honest though, actually, we can just, yeah, we won't bother with that. Oh, actually, we don't need the type. I'm going to keep it in there, but to be honest, star temperature should be sufficient. Why are we driving a color value in there? Oh, okay, that's for the cell value and that's for the color, right? So, okay, so we need to set these from our data that's coming in. So we'll simply convert that to a color value. So we will set color. We will set temperature. Then configure the star. And that should be enough for that to change. So if we change this, it gets increasingly more garish. Okay, so that's working. We're getting the right colours. I think what's happening actually is every time we move the slider, it's spawning in more of the effects, like the coronal rays and stuff. So we just need to make sure that we delete them all. So we are adding a bunch of static mesh components. What we'll do is we'll add all them to an array and then purge that afterwards. So these are just static meshes, so that's fine. So we'll call that star VFX. Make it an array. Let it do its thing, otherwise it complains. I'll take this time to pour some more mead. Hopefully that'll be quicker next time because it's indexed all now. Just add. Right, so all of these, we will add them all to the array. Add, and before we do any of that, we will clear in fact, before we do any of that, we will do for each, unless I can just do it straight from there. That might be easier. No, I can't. Okay. So we're going to destroy all the components. Then we're going to purge the array. And then we're going to recreate it again. Yeah, there we go. It's better. So it's not doing mad crazy stuff. So O-class star with its O-classness. B, A, F, G, K, and M. I still need to figure out why they're too big, but that's just a visual thing. I think I'll keep it so that the patterning on the star is visible, so that we're obviously, as we start inputting seeds into it, which will which we'll do now, you should be able to see the effect of that seed. So the process is as follows. We create something there, so call it star seed. So the seed can essentially be anything from -2 billion to +2 billion, because it is a 32-bit integer. So text box star seed. Yeah, that's sure all we need to do really. And then we need on committed. Well, this is going to have to get cleaned up eventually, of course. So we're going to convert it to. Actually, let's convert it to an. Do integer straight away? No, okay, to string first. And then a string to an integer. Okay, and then we'll save that value as an integer. Seed, and then obviously once that's done we need to update star like so, and then of course we are missing an important struct entry, so we need to go and add that to the struct. So we'll add star seed to there. Make it an integer. Pop that in there. And then on the star itself, which I've lost. Where is the star? Oh, that one. Yeah. We'll grab our star seed from here, and then we will set our seed. You should already be using that, yeah, for the material. So you can see we've got some like sunspots here. If I type in a seed value, you can see that they change. So 1, 2, 3, and so on. There's a bit of activity there. To be honest, I need to make them a little bit more obvious, don't I? Because they're not particularly well defined. Yeah, you can see some like holes there in the effect. Larger one there. Oh wow, there we go. Definite sunspots on that seed. Yeah, so the seed is driving the material on the star. So you can just like type something in and get crazy sunspots. This one is blue because it's an O class star. Make it an M class and it's not blue. I should make them ever so subtly not quite so bright, which we can do. Yeah, so our luminosity value there, we could actually do a clamped range. So if we do, hang on, let's check let's do it scientifically, check our actual values. So our maximum value is that. And our low value would be the M class, which would be that. So we could do 0.5 to say 5 for our luminosity value. And that should that should drive that. Don't need to care about that anymore, do we? Because we're not on the holo display. Let's give that a try. That's super bright, but let's see how it looks on here. So O to M. Right, we need to scale those values down. So M is fairly dim, whereas O, I suppose a bit too bright still. Well, actually, I think the problem with this is that obviously the range of temperatures below O class is actually quite compact. It's kind of an exponential scale, so really we want to cap it a lot lower than that. Probably more 10,000, because 10,000 should be around about the lower end of a B class, I think. Yeah, around about there. So yeah, we'll cap that at 10. That has just made it worse. Alright, let's do it the other way around. So 0.05 is too low. Let's keep that capped there. Maybe make that 50,000. Right, so low end M class would be that. And the O classes are crazy bright. So we don't really want the M to go much lower than that, to be honest. Yeah, given the huge scale, why don't we yeah, let's have a look at the range. So F caps out at 7. A caps out 10. So right, so let's do this instead. So if we do, where are we? So it's less than or equal to 10,000. And we'll have 2 ranges just to manage the scale somewhat better. So it's not lower than 10,000, then we will do the bigger range. So 10 to 50 would be, I guess, 1. Well, if we cap it at 1, maybe 0.5 to 1. And then the lower end of the range would be 0.1 to 0.5, and that would be from 2,500 to 10,000. So let's check the lower end of the M class. Still a bit too low, to be honest. I'd still prefer it to be around about there. And then upper end of the A class, still a bit too bright. Although let's just check our post-processing, because oh, there isn't one. Let's add a post-process again. Yeah, you can control that in the material. It slightly messes up the atmosphere effect around the outside, but yeah, it is something that we can fiddle with. Post-process, there we are. Let's make that infinite extent. Right, so on the exposure, can't remember what I set these to now, actually. I mean, auto exposure is disabled, but let's, yeah, okay, let's just assume that that's that, which means we need to make sure that we maybe do point 0.3, and then maybe 0.2. And then the B and the O go super bright. Okay, that'll do, I think. Give it some sunspots. Right, so that's that. Yeah, me too, Don. Yeah, I'm looking forward to building all the exciting stars and having having the jet plumes and all that sort of stuff. Great. Okay, so we've got our star configuration. So the next thing is we need to define some system variables. So we will have a system mass, and the system mass is basically a very small percentage of the star's mass. So we're using the mass of the central star to define what the mass of the protoplanetary disk would have been, and we do that in our star system generator. But I think let's just add that in here a minute. Right, so do we need anything else for the star? So we've got the star base class, star final class, we've got a slider for temperature, we've got a seed for the look of the star. Not that I'm aware of, Don. I think it's more yeah, I'm using the Sol system as an example. The mass of all the planets added together is like 0.001% of the star. It's a crazy tiny amount of mass. So that's what we're using as our defining characteristic for how big the protoplanetary disk would have been mass-wise. And then we can also drive like metallicity values by age and that sort of thing. As with system age, that's another thing, because the age of the system has a direct bearing on metallicity. And also, that's a fair point actually. So again, there's a chicken and egg problem here. So the age of the system defines the type of star that you can have. So you can't have an O-class star if the system is like 2-3 billion years old, because O-class stars don't last that long. So I think we might do it in a similar way to temperature, where you pick the class of the star, and then the age slider has a minimum and maximum based on that star type, and then we're not having to do any complicated fiddling around. Yeah, we'll do that one in a sec. Um, so if we have available system mass as a value that we track, and obviously every time you add a planet, it comes out of that system mass. So like an M-class system is going to have a lot less available mass to it than an O-class system. So you won't be able to have as many large gas giants in an M-class system as you would, say, a G-class system. Or you could use up all the mass on one giant gas giant and then have nothing much left over after that. When it comes to Kuiper belt style objects, I think we'll probably still handle those procedurally. Being that Kuiper belt style objects are technically not planets, those will just spawn as a scattered, loosely arranged disk beyond the final planet that you specify, beyond the... I can't remember what, I think it was the... See, it's not the hydrogen frost line. There's another frost line way out beyond Pluto, which kind of has a bearing on Kuiper belt location. I'll have to re-look that up. I've forgotten now. Yeah, and yeah, Dyson spheres will be a thing. Although Dyson swarms, more likely. They make more sense. And yes, Dave Soft, I agree. Mass budget fits better. Although I'll put system mass budget, so it's a little bit more clear. And that is in... I think it's actually expressed in kilograms in the code, so that's going to have to be human readable. So right now it's not. Galaxy location generator. Let's get rid of a bunch of these tabs. Yeah, so if for each class of star, where is it? Oh, do I do that later on, maybe? Yeah, there we go. Right, so yeah, so we're weighing the star in kilograms. So obviously that's a ridiculously large number. And then we define like a random system size. Now I think for the star system designer, we'll make that not quite so random. Let me just look up the Sol value a minute. So percentage of what fraction of the sun's mass is all of the planets combined. 0.14%. Apparently, I'm sure it's... I thought it was less than that. Oh no, that is right. So yeah, so the Sun is 99.86% of the total mass. Which begs the question, why are these fractions low? Yeah, so that seems fairly consistent. So when you round it up, it's 99.9%. So, well, actually, if we round it to 2 decimals, then it would be 99.85%. So if we say that 0.15% of the mass is the mass of the system, which means we need to first calculate the mass of the star. Let's check this for M class a minute, see if we're doing the same thing. Yeah, this stream's gone by really quickly for some reason. I guess that's what happens when we're deeply focusing on things. Exactly that, Claire, yeah. So I think we were using a lookup table to define that, which is probably coming from the Galaxy Gen. Yeah, so it is coming directly from the Galaxy Gen. So we'll need to... Yeah, we'll need to drag out these values from the Galaxy Gen and add those to this. So yeah, so before we can do the mass budget, which is going to be like that many kilograms, we need to calculate the radius of the star and its mass, and then we'll grab 15% of that mass, use that as our protoplanetary disk mass, which will be this value here. And then we also need the age, don't we? So so blah, 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 blah. I think what I'll do is, when we do the proper UI for this, I will group these in sections. So we'll have a protoplanetary disk section separately, which will have like the metallicity and what the mass of metals is versus the mass of volatiles. And I think we're doing that already. Protoplanetary disk. Oh yeah, there. So yeah, so we take the hydrogen, helium and metals fractions of the star, and then we work out therefore what mass in kilograms it would be for hydrogen, helium and metals. So when it comes to the UI here, we will automatically calculate just how much metallic mass there is within the star system. And that's relevant because for a really, really old star system that has a really low metallicity, you won't be able to have as much rocky mass within that system. For the oldest stars, they'll probably just be gas giants because there's no actual metallic mass within the system, because the system has such a low metallicity value because it's so old that it hasn't been through the whole supernova cycle to generate heavy elements. So we need to factor all that into this so that, again, it's scientifically plausible. I think because that's going to require more math than we have time for right now, let's just do the age of the star. So star age, or I guess system age. And that's going to be another slider. So slider system age. Yeah, so whenever we change the base class, that's what needs to change the system age, because the base class of the star determines the valid potential age of the star. So system age, and that's going to be expressed, well, we'll either do it in like billions of years, or we'll probably round it down to millions, so it will say like million years or billion years, depending on whether it's more or less than 1 billion. Okay. So blah 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 blah, star type. Yeah, so it had to be something we do here. So we're basically doing the same thing again that we were doing here, where we take that same star type value and we take the system. Oh, that's a text block. Slider, where is it? System age, there we go. So system age, and then we need to, I guess we need to express this in billions of years, millions of years. Right, this is going to require a bit of Googling. So O class star age range. Lifespan of O class stars is a short life, typically being 1 in 10 million years. I think we'll have to cap this at 1 million years. I mean, to be honest, all of them could have 1 as their low end value, because any of these can be newly born stars. Even like an M class, it could be a new M class. Okay, so typically 100, that's 200 million years. A class. Okay, so that's 1 billion. So what's that? So 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. It's about a billion, isn't it? So F, ooh, no, we didn't want to do that, did we? F class is up to 4 billion. And G class is 10 to 13. Which is pretty much the age of the Milky Way. So can't have anything older than 13.61. Yeah, because that's the age of the Milky Way, so nothing can be older than that. Speaking of which, we do have a bug that's making some systems older than that. Oh, see ya, Lapis. Have a good one. This is in millions of years. So that's 10 million years, 200 million years. And the reason O and B are so small is because they are giant stars that burn out very, very quickly. So they'll basically turn into supernovas like within 10 million years. They're very, very short-lived stars. Exactly that, yes. So you're right, actually. No, sorry. Yes, you are right. Of course, that's years, isn't it? Not millions of years. Yes. So that should be 1,000, 4,000, 13,000. Yeah, that's more like it. Yeah, this is in millions of years. So we also need to work out the age on there. And I think the way we'll do that is... Oh. And we need to do this as well, actually. So again, we'll just we'll give it a mid-range value. So we want big number minus little number, and then little number plus big divided number. Right, so that updates the slider. And then when that slider updates, on value changed, it's a shame there isn't a like on value committed, because like when you're changing the slider, it's automatically triggering a bunch of events, which causes lag. Right, so we'll set text on there. Then we want to format text. Right, so if it is greater than or equal to 1,000, got a plan. Then we'll take that and we'll divide it by 1,000. Yeah, so if it's greater or equal to 1,000, we'll divide it by 1,000, which means that would be one. Yeah, that kind of needs to go in there, really. So that would be age million years. And then this one would be billion years. So it's higher than 1,000. That goes to billion, otherwise it goes to million. So that would just be straight up million years, and we'll do that as to text because we want to get rid of fractionals. And then we'll do the same thing here, so to text, and then we'll keep 2 decimals on that one. That's for our billion years. Pop that in there, move that down there, tidy that up. Right, and that should update the text. Let's give it a try. Yeah, Unreal doesn't give you as nicer controls as that. Right, so 1 million. Into billions. Yeah, and then it caps at the age of the Milky Way. So there we go there. So if we go to an O class, then there we go. So we can't set the system age higher than 10 million years. B class takes us up to 200 million. And so on and so on. Right, so that means that we're keeping the age and data consistent and scientifically accurate, which is obviously important. And where this will change the star system is obviously the older the system, then the older the planets, and therefore the more likely it is they would have developed some kind of life. So like if you've got a G-class system and it's only like 463 million years old, then it won't have had time to develop complex life. So the system will have to block you from adding complex life on on a world that's that young. So we need to drive what is allowed based on these values, and that's also going to play into the actual procedural system as well. So the idea with the Star System Designer tool is that all of the values that you specify here are the same values and the same data that is used like in the actual procedural system. So there's nothing different about the two systems. What we're doing is we're giving you control over that procedural system so that you can force the values essentially. But because you're forcing the values, we obviously can't allow the forcing of values that don't make sense. So they at least have to be, plausible values. Okay, well, that just about takes us over time. So I shall be calling it a night there. But with oh yes, thank you, AJ. Yeah, you're right. Actually, we need some coordinates. I don't know how we're going to do the coordinate side of things. Probably maybe like a top-down view of the galaxy, and you can just drag a pointer around and pick a point in the galaxy, and it will like say, right, those are the coordinates for that point. We'll find some way of doing it. But yeah, and I think next Friday we'll probably do a bit more of this and start expanding this out some more. So the next step is defining the protoplanetary disk and all of its various values. And then once we have our protoplanetary disk defined for this system, then we can start looking at temperature regions and the creation of planets themselves. And then once we've defined the location and type of planet, and we've gone through all the protoplanetary disk data, then we can move on to the actual customization of those worlds. And we're going to have some kind of UI element where we can flick through them, to explore them and such. It's similar to how we've done this. So you'll see the planet on screen, and then you can change the seed and see how it affects the surface and all that stuff. But yeah, I think that'll do us for now. So have a great week ahead, and I shall see everyone on Sunday for our next stream. Right, see you soon. Bye.